All right, in this last example, we're going to learn how to fit a quadratic to existing data. The theater director at the high school wants to find the most accurate quadratic model for the ticket sales based on the data in example 3. How would the revenue be affected if the prices increase one more time? All right, so we're going to use a graphing calculator to do this. This process is called quadratic regression. And then just a reminder, that's one of the vocab words we put in our notes at the beginning of this lesson. Quadratic regression is a method used to find the quadratic function that best fits a data set. And we use a graphing calculator to do this. So the first thing we have to do with a graphing calculator is make sure that we turn on the stat diagnostics. So we're going to write out just a few steps on these, and then I'll have some videos that I'll insert in to show you what we're doing. So to turn on your stat diagnostics, you're going to hit the mode button on your calculator, and then you're going to find stat diagnostics. And then you're going to turn those on. In the first video, you'll see me do that step, but now you have it written out. You're going to go mode, stat diagnostics, make sure it's turned on. All right, so our first step for doing a quadratic regression is we want to enter in the ordered pairs of our data into our calculator. So to do that, here's what you're going to hit on your calculator, and then I'll show you what it looks like in a video. So you're going to hit your stat button, then the edit option, and then you're going to enter the X values into L1, that stands for list 1, and then you enter the Y values into L2. And the X values and the Y values, those are the ordered pairs from our table of values we had in example 3. All right, we can use our graphing calculators to do a quadratic regression. First step, however, we need to make sure that our calculator has the stat diagnostics turned on. So you go into mode. We're going to go all the way down to right here. You can see it says stat diagnostics, and they are turned off. We're going to arrow down and put our cursor on the on and hit enter there. The default setting for these calculators has those turned off for whatever reason, so we just have to make sure we turn them on when we're going to do something like a quadratic regression. Then you can hit second and you hit mode again and it will quit that screen. All right, we're going to enter in ordered pairs into our list 1 and our list 2. So you hit stat. We want this edit option. We can hit enter. And list 1, we're going to list our X coordinates, and list 2, we're going to list our Y coordinates. So in X1, the X coordinates are, for list 1, the X coordinates are 0, 1, 2, 3, and 4. This is coming from our previous example. And then in the list 2, we're going to list our Y coordinates, which is 745, 846, 910, 952, and 1008. One thing you just want to double check is that your ordered pairs are lined up horizontally, that the ordered pair 2 goes with the 910. So this looks good. This looks like the table of values I just took all those coordinates from.
All right, next you're going to use the quadratic regression feature. So here's how you find that on your calculator, and then I'll show you. You're going to hit the Stat button, then the Calc option, and then Quad REG, that stands for Quadratic Regression.
Now that we have our ordered pairs in our lists, L1, L2, we're going to calculate the quadratic regression. So we're going to hit the Stat button again. We're going to arrow over. We want this calc. We want this calculator to do some calculations for us. And if you look down, you can see option 5 says Quad REG. We want this to calculate a quadratic regression. What that's going to do is we're going to be able to write a quadratic function that is best fit to the data we have provided. So we scroll down to 5, we hit enter, and then we're just confirming, do we want the x's to come from list 1? Yep, that's where we put our x's. The y's will come from list 2. Great, that's where we put our y's. And then we're just going to enter through, enter, or on calculate, hit enter. What this gives us is our function in standard form, so we can see that this is the form we're going to work with, y equals ax squared plus bx plus c, and then they're giving us the a, the b, and the c values. So this -8 will plug in for a, the 95.2 will plug in for b, and the 749.8 we will plug in for c. And now we have a quadratic function. R squared, this value right here, this R squared equals 0.9935 and so on. That is helpful for us, and I'll talk about that in a second.
All right, so that quadratic formula I just said we could write, we would write it out as y equals -8x squared plus 95.2x plus 749.8. That is the best fit quadratic to our data that we had. Now let's talk about that r squared. What does that r squared tell us? So the closer r squared is to 1, the better the equation matches the data points. So you can see this r value is a 0.99. That's really good. That's a very high r squared. It's very close to 1, so that means that we have a really good equation. It's not 100% accurate, but it's pretty accurate. All right, step 3, graph the data, use trace to determine the predicted values. I am going to add in, you can use trace or the table. And let me show you how that works.
So to find the predicted revenue after the 6th and 7th price increases, we can use our trace. So I can trace, we want to know when x is a 6 and when x is a 7. So I can trace to do that. You notice sometimes it's hard to land it right on the 6, like right there is at a 5.909. I arrow over, I'm a 6.06. So for me personally, I would like the table of values. So I'm going to hit second graph. Here's our table. And I'm going to find when x is a 6. So this 6 represents the 6th price increase. What is the expected, or the predicted revenue, $1,033. The seventh price increase, or after the seventh price increase, our expected or our predicted revenue is 1,024.2. So the question is, what do you notice? Well, even when we look at the graph, we can see that after you hit a certain point, your revenue starts to decrease. And back in that table of values, we saw we were at 1,033 down to 1,024. So the revenue has started to decrease at this point.
All right, our last question. Use the model in example 4, so that's what we just were. And the model is what we had put into our graphing calculator, and we just saw the graph of that. Use that model to determine the predicted revenue after the 6th and 7th price increases. What do you notice? So the price increases are represented by our X values. Those are X's. So if we want to use our model to predict the 6th and the 7th, we essentially want to know what is f of 6, what is f of 7.
So once we have our quadratic function, we can graph this function and then we can use our trace or table to find predicted values. So to graph this, we're going to go to our y equals. It's very possible you already have some functions typed into your y equals, so we're going to clear all of that out. So clear, let's arrow down, hit clear. I'm going to go back up to y1, and we're going to type in that function that we wrote out. Y equals negative 8x squared. We got that negative 8 from our quadratic regression, plus 95.2 x plus 749.8. All right, so I'm going to hit graph so we can see what this looks like. It is an x squared function, quadratic, so parabola, with a negative a value, so opening down. So I'm going to hit graph, and what is this, right? So remember, sometimes our window is not fit to what our function actually is. So if we come over here to zoom, we can, first thing I would try is zoom, and if we scroll down, we have this zoom fit option. So oftentimes that's a good option. It should fit your window to what it thinks you want to see from your function. So we're going to hit enter and it will graph. That looks a little bit better. We can see that it is a parabolic shape. I can see the vertex is up here. If you hit trace, you can arrow over and you can see ordered pairs on the bottom. So if I needed to use this model to predict, when our x value is anything else, beyond what our table of values showed, we can use this as a prediction tool. Another way other than tracing is you can use the table of values. So if you hit second and then graph, you're going to get a table of values, and here we can scroll through and predict, oh, when x is a 12, we will have 740.2. Or when x is 17, we'll have 56.2. So sometimes the table of values might be a little bit easier to work with, but you can use both features. Either trace on your graph, so if I hit graph and then trace, you can just move that cursor left or right, or you can use the table of values.
All right, we saw that our predicted value when x is a 6 was 1,033, and when x was a 7, 1,024.2. And we just set it in that calculator video, but we can write in, the revenue has started to decrease. That's what we notice. That's what the question asked. What do you notice? We notice the revenue has started to decrease.